Hello students, how are you doing? I hope you are doing good. Well, Corona has given at least a lifeline to those students who were not prepared well before. Now use this lifeline and revise more, focus more and practice hard. And I hope you will be able to clear Neet entrance examination successfully. Okay, so today's topic is electrochemistry, and for convenience we have divided this topic into three subtopics. The first one conductivity cell, second one is electrolytic cell, third one is electrochemical cell. We'll begin our journey in this chapter from conductivity cell. So before we begin, what is conductivity cell? Let us have a quick look at the some terms and terminologies which will come across in this chapter. So the first one is resistance. All these things you already know that. Have a quick look. Resistance is the obstruction offered by the material in the flow of current, and its formula is R equal to rho resistivity into L by A. L is the length and A is the area of cross section of the resistor. Similarly, we have got resistivity. From here we can say resistivity is resistance into area upon length, and its unit will be ohm centimeter. Opposite of resistance is conductance. Resistance is obstruction offered in the flow of current. Conductance is the facilitation offered in the flow of current, and it is 1 by R, obvious from the definition, and its units are per ohm, mho or Siemens. Similarly, we have got conductivity. Conductivity is equal to 1 by R, L by A. Remember the units as well, per ohm per centimeter and Siemens per centimeter. This L by A is called cell constant. For a given cell, L by A does not change, it remains same. Now let us come to the definition of conductivity cell. So in simple words, conductivity cell is a cell which measures the conductance of a electrolytic solution. So what do I mean by that? I'll take a cell, put water into it and then drop electrolyte. When I'll drop electrolyte in water, since both electrolyte and water are polar in nature, the electrolyte will dissociate into cations and anions. The moment the electrolyte dissociate into cations and anions, it will be hydrated. I mean that the cation and anion will be surrounded by water molecules. Now if I apply voltage across the cell, the ions will start flowing in the opposite direction. Now when they will flow, the charge will flow, and that flow of charge is called conductance. When they will flow, they will also offer some resistance while crossing each other. So I can calculate the resistance. From resistance I can calculate conductance and conductivity. Now when the charges will flow, this flow of charge is dependent on various factors. What are those factors? So let's see that. Come on. So after knowing what is conductivity cell, let us understand the factors affecting conductance. So there are 6 factors we are going to discuss which will affect the conductance. Let us discuss them one by one. The first one is strength of electrolyte. The electrolyte can be strong or weak. Any strong electrolyte may be like salt, strong acid, strong base, and any weak acid or any weak base will suffice for weak electrolyte. Now the speciality of the strong electrolyte is that when they will dissolve in water, they will give more number of ions. More number of ions means more charge flow. More charge flow means the conductance will be high. But in case of weak electrolytes, the number of ions are less. They dissociate to a lesser extent. If number of ions are less, charge is also less. If charge is less, the flow will also be of a lesser charges. So conductance will also be less. So we can say that if we want more conductance, we should choose strong electrolyte. Okay? Now nature of solvent. Now we all know that electrolytes are polar in nature. Now if I will choose a polar solvent, I know that like dissolves like. So these electrolytes, they will dissolve more or they will dissociate more in polar solvent. Okay, so if I am using polar solvent, the dissociation will be more, I'll get more ions means more conductance. So if I am using polar solvent, conductance will again increase. Okay, now come to viscosity. Now it is very commonsensical. If viscosity is higher, it will be tough for the ions to move through that viscous solution. So if viscosity is higher, conductance will be low. We all know that if we have an open road, we can travel faster on that open road, but if we are stuck in a jam, traffic jam, the movement will be slow because traffic jam is more viscous in terms of vehicles. Now come to the fourth part, size of hydration sphere, very, very important. Now see, when the ions, they go in water, depending on their charge density, the hydration sphere size will also differ. More is the charge density, more is the size of hydration sphere. Now, bigger the size of hydration sphere, slower will be the movement. I'll take again the analogy of traffic. A bike can move faster in a traffic jam. Smaller hydration sphere can move faster. But a truck will take more time, it will move slowly. So bigger the hydration sphere, slower the movement of the charge, lower will be the conductance. So conductance will be lower. In case of bigger hydration sphere, conductance will be higher in case of smaller hydration sphere. Okay. Now come to temperature. We all know that if we increase temperature, kinetic energy of the ions moving in the solution will increase. If kinetic energy increases, velocity will also increase. And if velocity increases, yes, conductance will also increase. Conductance is all about the movement of charges. Faster the movement of charges, more is the conductance. Next one is concentration of solution. Now see what happens. If I have a concentrated solution of higher concentration, now see here the inter-ionic interaction is more. This negative charge, suppose it wants to move there, but it will be feeling a pullback from the cations. So its movement will be slowed down because of inter-ionic interaction. Over here, if I take a dilute solution, when I say dilute solution, the particles or the ions, they are far apart. When the ions are far apart, their inter-ionic interaction is low. This negative charge will feel a lesser pull force. So it will be moving faster. So I can say safely that if I have a dilute solution, the inter-ionic distance or inter-ionic interactions will be less, the movement will be faster. Here the pullback felt will be more, so the movement will be slow, the conductance will be low. Here conductance will be low, but in a dilute case the conductance will be higher. Okay, I hope this is clear. So students, from the point of view of chemistry, the two terms molar conductance and equivalent conductance are very, very important. Now see, what is molar conductance? The definition of molar conductance is the conductance when we dissolve 1 mole of electrolyte in a given solution, the conductance of that solution will be called molar conductance. Similarly, we can define equivalent conductance when we dissolve 1 gram equivalent of substance or electrolyte in a solution, the conductance of that solution will be called equivalent conductance. Now see the formula basically. The molar conductance at a given concentration is given by kappa, the conductivity, into 1000 divided by concentration in terms of molarity. The units will be per ohm centimeter square per mole or Siemens centimeter square per mole. Now remember, this is important, this thing is important. The reason being, here look at the units. This is meter square, here we are having centimeter square. So please look for the units. If the units are like meter square, please multiply by 10 to power of minus 3 and not by 1000. So when we have got units like per ohm, meter square, per mole, multiply by 10 to power of minus 3. Many people do not do that and they get a wrong answer. So this is important. Similarly, equivalent conductance is kappa into 1000. Here instead of molarity, we are having concentration in terms of normality. Remember that for molar we will go with molarity, for equivalent we will go with normality. So the units will change accordingly. Instead of per mole we will have per equivalent. Similarly, if the units are like meter square, we will multiply by 10 to power of minus 3. I hope this is very clear. Don't make a blunder out there. Many times I have found students doing a blunder. They do not see this and they, instead of this thing, they multiply by 1000 and they get a wrong answer. I hope this is clear. Okay, now let's move forward now. So students, we can now safely say, after understanding the factors affecting conductance, we can say that the conductance depends on two factors. One is number of ions, second one is ionic mobility. Ionic mobility in simple word means the speed of the ions. If we have got more number of ions moving with higher speed, the conductance will be more. Now let us see what will be the effect of dilution on conductivity, molar conductance and equivalent conductance. Let's take them one by one. Now see, first understand what is conductivity. Conductivity is the conductance in the unit volume solution. So suppose now I am having a unit volume of solution and I have some ions into it. So right now the conductance will be because of the 4 ions. But if I dilute this solution, then you will see that the number of ions per unit volume have decreased. So the conductance over here in unit volume solution is less now. It is just because of 1 ion. Number of ions have decreased. So conductivity will decrease on dilution, because conductivity is conductance of the ions in unit volume. Right now on dilution, the number of ions in the unit volume solution have decreased, and because of that the conductance will be less now. Now let's see the effect of dilution on molar conductance and equivalent conductance. For that, we should divide our electrolytes into 2 parts, strong electrolyte and weak electrolyte, and then see what will be the effect on these 2 factors, number of ions and ionic mobility. Now see, if I dilute a strong electrolyte, now strong electrolytes are those electrolytes which dissociate completely, whether they are in concentrated form or they are in the diluted form. The number of ions will remain same, that is alpha is constant. Alpha is 1 for strong electrolyte, it will not change. But ionic mobility will increase. Why? Because on dilution we have discussed that the inter-ionic interactions will decrease. Because of that, the movement will be faster. Okay, so out of these 2 factors, on dilution this will be favorable one. That means the molar conductance and equivalent conductance will increase in strong electrolyte because of ionic mobility increasing. Now come to weak electrolytes. I know that for weak electrolytes the alpha increases on increasing dilution. We know that from Oswald dilution law that K is equal to C alpha square, or you can say that alpha is equal to root of K by C. So if concentration decreases, that means dilution increases, alpha will increase. If alpha increase, dissociation increase, the electrolyte will dissociate to give you more number of ions. If more number of ions are there, conductance will be more. Now see, so this is factor which is favorable. This factor was not favorable for strong electrolyte. Now come to ionic mobility, same answer. On dilution, the inter-ionic distance will increase, and because of that the inter-ionic interaction will also decrease, and this charge will not feel the pullback force, so they will be moving faster. So in this case, for the weak electrolytes, both the factors increase to give you more conductance. So molar conductance and equivalent conductance will increase both in the case of strong as well as weak electrolyte, but relative increase will be more for weak electrolyte. Why? Because in a strong electrolyte only one factor is favorable, while in the case of weak electrolyte both factors are favorable. So for a given dilution, weak electrolytes will show more increase in molar conductance or equivalent conductance at a given concentration. I hope that is clear. So okay students, till now we have done qualitative discussion on conductivity cell. Now let's make it mathematical. So Debye Huckel, they were 2 scientists, they gave a law to find out the molar conductance. So molar conductance here is defined as, this will be equal to molar conductance at infinite dilution. This means infinite dilution minus B root C, where C is concentration, given concentration, and B is a constant. Now the problem with this formula is that how to get infinite dilution in laboratory. We cannot have ocean of water inside a beaker. So that is a problem basically. Now something which we cannot achieve physically, we try to achieve it mathematically. Now for strong electrolyte, whether you dilute it or make it concentrated, the number of ions do not change. So for here we don't have any problem of infinite dilution. I have to go into lab, take 2 readings, any 2 readings, and plot a straight line. And straight line, the best part of straight line is that it can be extrapolated. Since I cannot have infinite dilution, but by drawing a straight line and extrapolating that, I'll get molar conductivity at infinite dilution without doing it physically. So I will be able to get this for a strong electrolyte, because here the alpha is 1, that is constant. But that is not the case with weak electrolytes. Weak electrolytes are not that lucky. Why they are not lucky? Because on diluting, alpha will keep on increasing, and as a result the number of ions are not constant, they keep on changing, and I won't get a straight line, I'll get a curvature. And it is not easy to extrapolate a curvature. If I cannot extrapolate it, I will never be able to get molar conductivity at infinite dilution. If I am not able to get it, this formula is not workable for weak electrolytes. So to solve the problem of weak electrolytes, we have a new law that is called Kohl-Rosch law. So come on now, let's study that. So students, just now we saw that Debye-Huckel law is giving reliable results only for strong electrolytes but not for weak electrolytes. So for weak electrolytes, we have Kohl-Rosch law. Kohl-Rosch gave, two statements. The first one is that molar conductance at infinite dilution of any ion is constant. It is independent of any interaction, inter-ionic interaction. We knew that at certain concentration there is inter-ionic interaction, and because of that there is a pull force. But at infinite dilution, molar conductivity of that ion will be constant. There will be no interference, no resistance coming from any other ion, independent of the source of the ion. Whatever the source of the ion, for example, I am talking about, suppose say H ion conductance. So it might come from CH3COOH, which is the weak electrolyte, or it might come from HCl, which is a strong electrolyte. In both the cases, the H ions at infinite dilution will give you same conductance. Now see, molar conductance of an electrolyte is equal to summation of the molar conductance of all the ions present inside the solution. Let me explain this thing. For example, I have to find out molar conductance of NaCl. So this statement says that molar conductance of NaCl will be equal to the molar conductance of all the ions in NaCl inside the solution. So that will be the summation of molar conductance of Na plus and plus molar conductance of Cl ion, because there are only two ions. Now molar conductance of MgCl2. Now 1 molar MgCl2 will give you 1 molar Mg ions and 2 molar Cl ions. So the molar conductance of this electrolyte will be molar conductance of Mg ions plus 2 into molar conductance of Cl ions. Why? Because we have got 2 Cl ions and only 1 Mg ion. So I have to multiply by 2. Molar conductance of AlCl3 similarly will be molar conductance of aluminum ion and 3 into molar conductance of Cl ions, because in 1 mole AlCl3 we have got 3 Cl ions. So I will have to multiply by 3. Now come to this point. This is equivalent conductance. Equivalent conductance is equal to molar conductance at infinite dilution divided by the valency factor. We all know that number of equivalents is equal to what? Number of moles divided by valency factor. Okay, so now let's see that. Molar conductance, there is a question, molar conductance of Na plus will be equal to X. This is given. Molar conductance of Cl ions is equal to Y. They are asking you find the molar conductance of NaCl. Now the molar conductance of NaCl will be what? The conductance because of the Na plus and Cl ions, which is given as X, and this is given as Y. So answer will be X plus Y. Equivalent conductance of NaCl they are asking. That will be molar conductance of NaCl divided by the valency factor. Valency factor of NaCl is what? 1. Because we have got 1 positive or 1 negative charge. So this will be X plus Y divided by 1, or simply X plus Y. In the next question, they have given you molar conductance of magnesium ions. It is having 2 plus charges, and Cl ions, that is Y. From here we know that molar conductance of MgCl2 will be what? Molar conductance of Mg ions, that is X, plus, since in MgCl2 we have got 2 Cl ions, this will be 2 into Y. Now they are asking equivalent conductance of MgCl2. To get equivalent conductance of MgCl2, I should divide the molar conductance by valency factor. The valency factor of Mg plus 2 plus is 2. So it will be x plus 2y divided by 2. So this is how we are going to handle the questions of molar conductance and equivalent conductance at infinite dilution. Let's solve some more questions to make it more clear. Okay. So now let us see an application of Kohlrausch law. We are supposed to find out the molar conductance at infinite dilution of acetic acid, which is a weak electrolyte. Now when we will be doing infinite dilution, the molar conductance of CH3COOH will be given by molar conductance of CH3COO negative and molar conductance of H ions. It will dissociate into acetate and H ions. Now my purpose is to get this and this. Now in these kind of questions, they will give you the molar conductivity at infinite dilution of all the strong electrolytes. CH3COO is a salt, strong electrolyte. HCl, a strong acid, strong electrolyte. NaCl, a salt, again a strong electrolyte. Now by using the data from the strong electrolyte, we will be solving this question now. Now see this. Now do one thing, whatever I require acetate ions and H ions. Now look into these equations. Add those equations which are useful for you. When I say useful for you, I mean which contains acetate ions and H ions. So equation 1 contains acetate ion, equation 2 contain H ion. Add these two equations and subtract the equation which is not useful. So when you will add first and 2, add 1 and 2 and then subtract 3 from that. So when you will subtract the third, what will happen? This Na plus will be cancelled, this Cl will be cancelled, and what I did, I added 1 and 2 and subtracted 3. So molar conductance of CH3COOH will be equal to what? Now I am left with what? I am left with only acetate ion and H ion, which is what I require. How I got it? I got it by adding first 2 and subtracting third. So answer will be x plus y minus z. Okay? I hope it's clear. So now let's quickly see the next question of the same format. We have to find out the molar conductivity of barium sulfate with the help of this given data. Now this will be actually equal to, according to Kohlrausch law, molar conductivity of barium ions and plus molar conductivity of sulfate ions. I need this thing with the help of this data. Now I told you I require barium ions, I require sulfate ions. In the first equation I have got barium, in the second equation I have got sulfate. So I'll add these two equations, but remember that I do have 2 H ions and 2 Cl ions. But here in this third equation, before subtracting, see that I have only 1 H ion and 1 Cl ion. I should delete 2 H ions and 2 Cl ions. So what I'll do, I'll multiply this by 2. So this will become 2 and this will also be 2. Now if I subtract the third equation from 1 and 2, I'll be getting this will be cancelled. This will also be cancelled. So I'll be left with barium ion and sulfate ion. So molar conductivity of barium sulfate at infinite dilution will be because of what? X plus y minus 2z. So that's the answer. But now if they ask you equivalent conductivity of barium sulfate, now remember that over here we have got valency factor is 2. So equivalent conductivity will be x plus y minus 2z divided by 2. Okay, simple one. Okay. So students, we have two formulas which we have to learn by heart, because Neet has been asking certain questions on these two formulas as well. This is called degree of dissociation, and that is given by molar conductivity at a given concentration divided by molar conductivity at infinite dilution. This is very important. Also, when you talk about ionic equilibrium, there is a topic called solubility product. So there is a topic called solubility for sparingly soluble salts. That solubility S is equal to kappa into 1000 divided by molar conductivity at infinite dilution. You have to learn these two formula by heart. Now for example, I have a sparingly soluble salt like AgCl. It will dissociate to give you Ag ions and Cl ions, and let the solubility be S, then the concentration of Ag ions and Cl ions will be SS each. So Ksp of a salt like AB category is S square, we all know that. So let's see some application of these two things one by one. So in this question they have given that for a given salt or a acid or whatever, molar conductivity at a given concentration is 10 Simon centimeter square per mole, and that at infinite dilution is 200. Now what will be alpha? It is directly a formula based question, so alpha will be molar conductivity at given concentration upon molar conductivity at infinite dilution. This is given as 10, this is given as 200, this will be 1 by 20. Simplify that, you will get 0.05 or simply 5%. So alpha will be 5%. This signifies that whatever the salt is given or electrolyte is given is a weak electrolyte. Okay, now let's see an application of this formula as well. Okay, so let's solve one more question based on solubility product. Here they have given you kappa conductivity of AgCl, which is 2.8 10 to power minus 6 Siemens per centimeter. They have also given you molar conductivity of Ag plus and Cl ions. They are asking you Ksp of AgCl. Now to find out Ksp, I need to have solubility, and the formula for solubility is what? Kappa into 1000 divided by molar conductivity of AgCl at infinite dilution. Now I know that molar conductivity at infinite dilution of AgCl is equal to what? Summation of the molar conductivities of the ions. So that will be molar conductivity of Ag ions plus molar conductivity of Cl ion. So this is given as 60 plus 80. So this will be 140 Siemens centimeter square. Look at the units also, per mole. Now I got this, I know kappa, I can calculate solubility. So solubility from here will be, kappa is given as 2.8 into 10 to power of minus 6 into 1000 divided by 140. You solve it, you will get 2 into 10 to power of minus 5. And Ksp for salt like AgCl, Ksp is S square. So answer will be 4 into 10 to power of minus 10. Simple one, I believe. Okay, let's move to the next question now. So students, we have got 3 beautiful questions but simple questions, and these kind of questions Neet has been asking again and again. So these questions, they depend on your conceptual clarity. So let's check it out. First question is, which of the following 4 will give you highest conductivity? All are having same concentration. This is CH3COH, CH2ClCOH, CH2FCOH and CHF2COH. Now we know that conductivity or the conductance, it depends on the number of ions present. More the number of ions, more is the conductivity or conductance. Now let us check out what will decide that when the number of ions will be more or less. Now more ions will be formed only if they are stable in the solution. So if you check out the 4th option, you will see that when it dissociates, it will give you C, H, F, F, C, OO negative and H plus. Now we have got 2 fluorine which are highly electronegative. So now because of the minus I effect of fluorine, 2 fluorines, the negative charge will be dispersed. More is the dispersal of the charge, more stable is the species. More stable is the species, more it will be formed in the amount. So among these 4, CHF2COH will dissociate to a greater extent, giving more number of ions. So more number of ions means higher conductivity or conductance. So answer will be 4th. In CH2F, only 1 fluorine is there to disperse the charge, and in CH2Cl, chlorine, but chlorine is not that electronegative as compared to fluorine. So clearly the 4th one is the right answer. Now come over here, highest resistance. Now resistance in solution, depends on what? Inter-ionic interaction. And inter-ionic interaction depends on the concentration. More the concentration, more closer are the ions. More closer the ions will be, more will be the inter-ionic interaction. They will pull each other more. So highest resistance will be shown by that solution which has more concentration. So the more concentration among these four is third one. Okay. Now come over here. Increasing order of the mobility of these ions. To solve this question, first we need to understand that hydrogen ions, H plus ions, they are the fastest travelers in water. So they will be moving fastest because they have a different mechanism of movement. They move via Grothus mechanism. Second fastest is OH ion. Now let's compare these three. Now I told you that when you will put the ions in the solution in the water, they will be having a hydration sphere. The size of the hydration sphere will depend on what? Charge density. Now you know that lithium ion is the smallest of these three. So, and sodium ion is bigger than that, and K ions, potassium ions are still bigger. Now the charge density will be more on lithium. So if higher the charge density, higher or bigger will be the hydration sphere. On sodium, the sphere will be bigger but not that bigger. On potassium, it will be smaller than sodium. So bigger the size, slower the mobility, slower the movement. So lithium ion will be moving slowest. So this will be slowest, faster, and the fastest one. So that is the right order of mobility or the movement in the solution. Okay. Let's do one more question now. This question says 500 ml of aqueous solution contains 0.1 mole of solute. They're saying if kappa is X Siemens per centimeter, find molar conductance at this given concentration. So I know that molar conductance at a given concentration is kappa into 1000. Why 1000? Because I know that units are in per centimeter divided by concentration in terms of molarity. So kappa is X into 1000 divided by concentration in terms of molarity. What is molarity, by the way? Molarity is number of moles upon volume in liter. So number of moles is how much? 0.1 mole divided by volume 500. This is ml. So what you will do to convert ml into liter? Multiply by 1000. So when you will do that, 1000 will be cancelled. This will go up and this will give you 500x upon 0.1. This will be 5000. What? 5000x Siemens centimeter square per mole. That will be the answer. Simple one, I believe. Okay. But these kind of questions they are asking. Yeah? So please keep on practicing these questions. Let's do one more question. So come, let's see this question. They're asking you molar conductivity at infinite dilution and equivalent conductivity at infinite dilution of this salt, COK and CONA. They have also given you molar conductivities of the responsible ions. Now I know that from Kohlrausch law that the molar conductivity of COOK, COONA will be because of what? Molar conductivity of all the ions. This will be molar conductivity of COO negative and molar conductivity of Na plus molar conductivity of K plus. Now you add it, you will get what? This is 150 plus 50 and plus 75. This will be 275 Siemens centimeter square per mole. This will be the molar conductivity. Now to get equivalent conductivity, what I have to do? Divide the molar conductivity by the valency factor. Now the valency factor for this salt is how much? In this ion I have got 2 negative charges or 2 positive charges. So valency factor will be 2. So equivalent conductivity will be how much? 275 divided by 2 Siemens centimeter square per equivalent. I hope this is clear. Okay.